students, today we'll begin with a new chapter and the name of chapter is circles. So next we'll start with the theorems which are based on inscribed angle theorem. The first is angle inscribed in a semicircle is a right angle. Angle inscribed in a semicircle is a right angle. This is the first theorem. We'll do one more. This is converse of this one. Theorem. This is converse of before. Previously it was angle inscribed in a semicircle is a right angle. Converse is if an angle is a right angle. If an angle is a right angle, then arc is a semicircle. If an angle is a right angle, then the arc is semicircle. See the first one. Given to us one circle, center. So I'll write it down, which all given to us. Given circle with center O. Point AB, and there is one angle. Now if you look at angle inscribed in a semicircle is right angle. Now in this case, angle APB is inscribed in arc APB. When I have explained you inscribed angle, intercepted arc, inscribed arc, that time I have told you जो arc angle बनाने के लिए लगता है उसको inscribed arc बोलते हैं. यहाँ पर ये एक inscribed arc है और ये semicircle है. Why it is a semicircle? Because ये diameter है. Why it is a diameter? Because it is passing through center O. हम लोगों को प्रूफ करना है. To prove angle APB is equal to 90 degree. I'll write this also. Arc APB semicircle. This is also known. And we need to get the answer. Angle APB is equal to 90 degree. Proof of this. Angle APB is an inscribed angle is equal to half measure arc. Now if I name one more point over here, Q. So angle APB is equal to half measure arc AQB. Reason is inscribed angle theorem. Right? Half measure arc AQB. Now if you look at arc AQB makes 180 degree angle. This angle is 180 degree. Right? But measure arc AQB is equal to 180 degree. Reason is measure of semicircle. Measure of circle is 360, measure of semicircle is 180 degree. Therefore, angle APB is equal to half of 180 degree. Angle APB is equal to 90 degree. Next is converse of this one. Same thing I am writing. ABO angle is APB. But this time it is given to us angle APB is 90 degree. Given angle APB 90 degree. To prove, this time we need to prove arc is a semicircle. To prove arc APB semicircle. Just the converse of before. Proof of this, angle APB is equal to half measure arc AQB. Reason is inscribed angle theorem, like last time. Therefore, 90 degree, as angle APB is 90 degree, is equal to half measure arc AQB. Therefore, measure arc AQB is equal to 2 into 90, 180 degree. So measure arc AQB is 180 degree. Therefore, arc AQB is a semicircle. So this arc becomes a semicircle. Result is, therefore, R APB is also a semicircle. This is what we wanted. So we got two answers now. First, कोई भी एंगल जो सेमीसर्कल में बनता है वो राइट एंगल होगा. कन्वर्स, अगर कोई एंगल राइट एंगल है तो जिस आर्क पे वो बना है वो आर्क सेमीसर्कल होगा. Angles formed interior of circle, angles formed exterior of circle. And the next would be angle formed exterior of circle. Take 2. In this case, this is the angle which is formed interior of the circle. In this case, angle formed exterior of circle. So I name it AB, CD, this point P, same way. AB, CD, and I'll name this point as P. Now if angle is formed interior of circle, as per this theorem, the measure of angle, this time angle is BPD. Angle BPD is equal to half, this angle is half sum of intercepted arc. In this case, angle is BPD. Angle BPD is equal to half difference of intercepted arc. If you make out this angle, these are intercepted arc. In fact, this is an intercepted arc, and this arc is intercepted by a vertically opposite angle, but for convenience I am just calling it sum of intercepted arc. This time this angle is intercepting two arcs. This is one arc because this arc is coming in between this angle, and this is your second arc. So measure of this arc is half difference of these two arcs. In this case, this angle was half sum of these two arcs. Right? This is the theorem. So we'll get the answer now. Proof of this. For that, we'll make a construction. Construction is, what I'll be doing is, to get this angle, I am joining BC. Join BC. So we'll start with the proof now. Now you can make out, this is one angle, right? This is one angle. This angle is intercepting this arc, right? And this angle, this is the angle which is intercepting this arc. So we are getting these two angles, and these two angles, this is one triangle, this is exterior angle. Hope it is clear. Look at this triangle. In this triangle, this is one angle which is intercepting this arc. Second angle intercepting this arc. But these two angles are related to this angle by remote interior angle theorem, right? So I'll start with this angle now. Okay, this angle. So to read this angle, I can call this as arc ABC. Angle ABC is equal to half measure arc AC. Inscribed angle theorem. Same way, I have told you second this angle, that is angle ACB. Angle ACB is equal to half measure arc BD. Again, inscribed angle theorem. Now, required angle BPD. Angle BPD equals to, angle BPD is equal to sum of remote angles, that is angle ABC plus angle ACB, remote interior angle theorem. Therefore, I can write angle BPD equals to, instead of ABC, I can write this arc, that is half measure arc AC plus half measure arc BD, because ACB value is half measure arc BD. Therefore, angle BPD equals to half common measure arc AC plus measure arc BD. This is what we wanted, right? Half sum of intercepted arc. Same result we have got. Angle APD is equal to half sum of intercepted arc. Arc AC and arc BD. Now in the second case, we require angle formed is equal to difference of intercepted arc. For this, we'll join BC. Construction, join BC. Proof of this. Same way we are going to get the answer. This angle is equal to sum of these two angles. This angle and this angle. Now this angle is half of this as per inscribed angle theorem. This angle is half of this as per inscribed angle theorem. So I'll write down that. First is angle ABC. This time I'll write ABC like last time only. Angle ABC is equal to half measure arc AC. Reason is inscribed angle theorem. So ABC we have written down. Second time. Second we require this angle. Angle BCD. Right? This is angle BCD is equal to half measure arc BD. Again, inscribed angle theorem is the reason. Also, angle BCD is equal to sum of these two angles, remote interior angles. Now this angle is angle BPD plus angle ABC, right? These two angles. Reason is remote interior angle theorem. So we'll substitute values now. BCD is half measure arc BD. Half measure arc BD is equal to BPD relation we need to get plus angle ABC is half measure arc AC. So half measure arc AC I'll bring this side. So I'll get angle BPD is equal to half measure arc BD minus half measure arc AC. Now if we take half common, so we'll get half measure arc BD plus measure arc AC, right? Because we have taken half common. This is what we wanted. So when angle is formed inside, answer is half sum of intercepted arc. When angle is formed outside, answer is half difference of intercepted arc. So half measure arc BD minus half measure arc AC. This is minus sign, half measure arc AC. So in this case it is difference, in this case it is sum. These are properties which are based on inscribed angle theorem, because you can make out in both cases we have applied inscribed angle theorem. Next theorem is angles which are inscribed. Angles inscribed in a same arc are congruent. Angles which are inscribed in a same arc are congruent. Circle. This is one angle ABC. Now if you observe, this angle ABC is inscribed in arc ABC. This angle ABC is inscribed in arc ABC. If I take one more angle, ADC, so you can make out angle ABC, angle ADC, both the angles are inscribed in the same arc. Rather we can say ये दोनों जो एंगल है इनके बीच का आर्क कॉमन आ रहा है. अगर ऐसा कंडीशन होता है तो ये दोनों आर्क इक्वल होंगे. Angles inscribed in a same arc are congruent. These two arcs are inscribed in a same arc, so they are congruent. So given angle ABC, angle ADC, and a circle to prove angle ABC is equal to angle ADC equals to or congruent to. Very simple to prove. Angle ABC is half measure arc AC, half measure arc AC as per inscribed angle theorem. Inscribed angle theorem. Same way, angle ADC is equal to half measure arc AC. Reason is same, inscribed angle theorem. So from these two, we can say that angle ABC is equal to angle ADC. Why? Because right hand sides are equal, so left hand side will also be equal. This is what gives the answer. That is, angles inscribed in a same arc are congruent. So what we'll do now is, till now, how much we have done in circles in terms of theorems, we'll revise all that so that we can start with the sums next. So we have begun with tangent perpendicularity theorem. After that, we did converse tangent perpendicularity theorem. Then we did one more, that is tangent segments from exterior point are congruent, right? Then after that, we did inscribed angle theorem. Then angle in a semicircle theorem. Angle in a semicircle. Then converse of angle in a semicircle theorem. Then after that, we did angles inscribed in a same arc congruent. Angles inscribed in a same arc. Tangent perpendicularity theorem was circle, tangent, center, radius. So I can write O center, line L tangent. If line L is tangent and OP is radius, The result is angle P 90 degree. Tangent perpendicularity theorem. Tangent radius makes 90 degree angle. Converse. Known to us radius, known to us a line, known to us this angle 90 degree. Line L, point P, center O. So this time OP radius, angle P 90 degree. Then we can say line L is tangent. Converse of tangent perpendicularity theorem. Third, tangent segment from exterior point congruent. Circle, exterior point, point P, A, P. If this happens, we can say PA is equal to PB. Tangent segment from exterior points are congruent. Then inscribed angle theorem. In a circle, inscribed angle is half the measure of intercepted arc. Angle equals to half measure of intercepted arc. Next we did angle formed in a semicircle. Now in this semicircle, if this is the angle formed, this angle will be 90 degree. Right? If semicircle is there, then angle equals to 90 degree. Converse of this, we know this angle 90 degree. If angle equals to 90 degree known to you, then the arc where the angle is formed, that is semicircle. Then arc is semicircle. Then angles inscribed in a same arc, same what we have done. Circle, these two angles, if these two angles are formed in a same arc or common arc, we can say angles are congruent. These two angles will be same. If this angle is 30 degree, this angle will also be 30 degree. Angles are congruent as per angles inscribed in a same arc theory. So let's start with some problems based on inscribed angle theorem, which we have done. I'll take 2.3 sums, exercise 2.3, first sum first, then I'll take the second one. There is a figure drawn. Now in this, there is one angle given 80 degree. There is one angle given 80 degree, and name of this angle is ACB. Vertex A 80 degree, ACB. This side is point Q and this side is point P. And this is joint. This is 2.3 first sum. Now the question is, measure arc APC is 60 degree. Measure arc APC is equal to 60 degree. Then after that, measure angle BAC 80 degree. Angle BAC is 80 degree, which I have already marked. We need to find out angle ABC first, and one more. The second is measure arc BQC. Measure arc BQC. So measure arc APC given to us 60 degree, and we need to find out angle ABC and measure arc BQC. Solution of this: this angle 80 degree, measure arc APC. Now APC means central angle. Now if this arc is 60 degree, this angle will become 30 degree because this angle is inscribed. This angle, as per inscribed angle theorem, inscribed angle is half of intercepted arc. Now if arc is 60, angle has to be 30, half of it. So we need to find out two answers, ABC and BQC. So I'll start with it. Angle ABC is equal to half measure arc APC by inscribed angle theorem. Therefore, angle ABC is equal to half of 60 degree because arc APC is 60, angle ABC 30 degree. Second, we need to find out measure arc BQC. Measure arc BQC. This is your arc BQC. Right. Now this arc BQC is an intercepted arc. For which angle? Angle BAC. Also, angle BAC is equal to half measure arc BQC. Reason is same, inscribed angle theorem. Therefore, angle 80 degree is equal to half measure arc BQC. Therefore, measure arc BQC 2 into 80, 160 degree. This is how you have to get the answer. This is going to be a 2 mark sum. For this answer, you will get 1 mark. For this answer, you will get 1 mark. To get this answer, there has to be a reason mentioned. To get this answer also, you have to write the reason. That means you can say half marks for this, half marks for this answer, half marks for this reason, half marks for this answer. Total becomes 2. We'll take another problem, second sum from exercise 2.3. Exercise 2.3, second sum we'll take now. Now in the second sum, they have mentioned there is a right angle triangle. In a second sum, question is, there is a right angle triangle whose vertex is on a circle. So I'll draw this way. There is one right angle triangle. Question is, right angle vertex is on the circle. I'll read out the question. Find the radius of a circle passing through the vertices of a right angle triangle when length of perpendicular sides are 6 and 8. So I'll name it ABC, given to us. Triangle ABC, angle B 90 degree, AB equals to 6, BC is equal to 8. To find radius of circle. Solution. This side is 6, this side is 8 given. Triangle ABC, angle B 90 degree given. Therefore, we can write AC square is equal to AB square plus BC square by using Pythagoras theorem. Therefore, AC square is equal to 6 square plus 8 square. AC square is equal to 36 plus 64. AC square equals to 100. That gives you AC as 10 by taking square root. Point which you need to note now. This angle is 90 degree. This angle is formed on a circle. This arc becomes a semicircle. Arc ABC becomes a semicircle. Therefore AC becomes a diameter. But AC is a diameter. Why it's a diameter? Because arc ABC is semicircle. Angle formed in a semicircle is right angle. Therefore, radius R is equal to half of diameter, that is half of AC, that is half of 10, that gives you 5. Again 2 mark sum, 1 mark for finding out diameter and 1 mark for finding out radius with the reason. You need to write the reason why it's a diameter. Accordingly, you can get the answer. So we have taken 2 sums. In the first sum, we have used inscribed angle theorem nicely, just to make sure that you have understood the concept well. In the second sum, we have used angle in a semicircle property. by which we came to know it's a diameter and we got the answer. Next we'll take a problem from a problem set. From circle problem set, we'll take one problem and the problem goes this way. There is one circle which is inscribed in a triangle like this, and name of the triangle is ACB, radius of the circle is R, this is how it is marked, point R, point P given to us, opposite to vertex B, small b, opposite to vertex A, small a, opposite to vertex C, small c, and radius is R. Plus this is given, angle C 90 degree given to us, angle C is 90 degree, radius is equal to R, sides are A, B, C. We need to prove 2R is equal to A plus B minus C. This we need to prove. 2 times of radius is equal to A plus B minus C. Again, things which are given to us: angle ACB 90 degree, that is angle C 90 degree, radius is R. In this triangle, this point is R, this point is P, this angle is 90 degree. This answer we need to bring. Proof of this. First thing, look at this quadrilateral. I'll name this point as O. Look at this quadrilateral. Now in this quadrilateral, I'll mention the reason. O center given, AC tangent. Why? Because it is touching a circle. Therefore, angle P 90 degree, tangent perpendicularity theorem. Same way, O center, this time BC tangent, BC is tangent, therefore angle R 90 degree, tangent perpendicularity theorem. Angle C 90 degree given to us, therefore angle O will also be 90, fourth angle of a quadrilateral. Also, if you make out, OP is equal to OR is equal to R, that is radius of the same circle. Result is all angles are right angle, adjacent sides congruent. Now if you remember, we have done one similar sum like this, where I have explained you that in a rectangle, if adjacent sides are equal, then that rectangle becomes a square. Same thing is happening here. All angles are right angle. All angles are 90 degree. Therefore, it becomes a rectangle. And in this rectangle, adjacent sides are also equal. So it becomes a square. Therefore, quadrilateral PORC becomes square. Therefore, now square means all sides equal. Therefore, OP is equal to OR is equal to CR is equal to CP, that is equal to R. All sides are R. So I can write all sides as R now. Now if all sides are R, so this remaining portion, I can write BR plus CR is equal to BC, segment addition property, right? We can add these two segments, BRC. Therefore, we can write BR plus R is equal to A. Therefore, BR becomes A minus R. Same way, if you look at this side, AP plus CP is equal to AC. Why? Because APC is a straight line. Therefore, AP plus R is equal to B. Therefore, AP becomes B minus R. So we got this value as A minus R, as you can make out here, and this is R, this one is B, so this becomes B minus R. Again, BR is equal to BC. Why? Tangent segment from exterior points are congruent. BR is equal to BC. Therefore, BC becomes A minus R. Therefore, this value becomes A minus R. Same way, AP is equal to AC. This value is B minus R. So, this value also becomes B minus R. That is B minus R. So, we got this as B minus R, this as A minus R. At last, look at this line, AB. Now, AB is what? AB is C. So, I write down that AB is equal to AC plus BC, segment ACB, straight line. So, now AB is C, small c, AC is B minus R, AB is A minus R. So, we get C is equal to B minus R plus A minus R. This minus R minus 2R. Minus 2R, if you bring other side, it will become 2R. This side what remains? A, B minus C. A plus B minus C. This is what our answer is. A plus B minus C. So what we have done in this sum? What we have done is, we have applied segment addition property. We have applied length of tangent segment from exterior points congruent, that theorem. After that, we have applied property of a square. How we have done this? First we mentioned that it's a square. To get a square, we applied tangent perpendicularity theorem. 90, 90, 90 given. So becomes a rectangle. Then adjacent sides congruent becomes a square. After that, segment addition. Again segment addition. Length of tangent segment from exterior point congruent. And the final answer.